Okay, this is the kind of catenary thing. As you can see, the green catenary would start out like this. As it fills up with water, it's getting smaller, pulling fabric from beneath it until it reaches a kind of maximum capacity, at which point water will start to overflow from here into this catenary, like so. This is getting bigger and bigger and bigger. This catenary, if it were slightly larger than this one, which would reach like a tipping point, at which point it would start to, I think, because the mass or the weight in here would be lighter than this one, would start to pull fabric back down, making this get even bigger, expanding in this direction. And consequently causing the catenary above it to shrink as it's, or squeeze the kind of water out of it. And this wouldn't happen, but this extra slack would be kind of diverted to here as this water, as this pouch got filled up. There's an idea that these little points where the fabric is going over them would actually be some kind of rod or gear which would be able to capture the work or the turning of that thing to charge a capacitor or something like that, maybe to generate whatever electricity is needed for the thing, instead of using solar power to use that kind of mechanical work. This would kind of, I don't know, stair step or kind of kick down the system, so there's this kind of perpetual kind of cranking of the rods and stuff like that. This is executed over here in Grasshopper. Let's see if we can turn this stuff on. This is generated by 2 frames, 2 cell or a grid of cells, and so this could kind of propagate across this surface. Right now it's modeled to be 36 by 36 inches, and it's divided into, so this is a 36 inches, each cell is 3 inches wide by 6 inches tall. What I'm doing is taking that 36, so this, if you see that 36 could get larger, and if you see that, it's getting larger, smaller, and kind of propagates across it. Yes. Then the stuff is ending.